Hello and welcome to this module on sniffing traffic. Let's see what we'll be doing. We'll start with what is traffic or packet sniffing, and then follow that up with how do we go about sniffing network traffic. We'll talk about what are we trying to achieve with sniffing traffic. We'll also look at the tools we'll be using in the demo later. And then finally, we'll look at what countermeasures are put in place to prevent vulnerabilities in network traffic sniffing. Let's move on. So what is traffic sniffing or packet sniffing? Well, if you look at the definition, it's network traffic or packet sniffing is the interception and logging of network traffic as it passes over a computer network. So what do we mean there? Well, in essence, if you look at the TCP/IP stack in a network, it's all made up of packets that are sent millions of times per second between different computers and routers and switches, etc., etc. So I mean, I'm hoping that you guys have a basic understanding of how networks work. So packet sniffing is literally intercepting those packets as they travel around the network. So when, for example, this computer here sends a request to the server there, it'll send a number of packets to that server, and then that server will respond with a number of packets back. And packet sniffing is actually looking at the packets, intercepting them and logging them as they travel over the network. Then to do packet sniffing, you generally need a packet sniffer, and you get hardware and software based packet sniffers. So a hardware packet sniffer is just that, an appliance that you put on a network that does the same thing. And then you also get software that can run on virtual machines or on servers or whatever that actually do the traffic sniffing for you. In this module, we'll be looking at traffic sniffing using the Kali Linux operating system. So how do we go about sniffing network traffic? Well, we need to get our network basics down. So for you to be a good packet sniffer or a good packet analyzer, you need to have a very good understanding of your network basics. And let's just look at a few principles that are very pertinent to network or packet sniffing. First one is ARP, Address Resolution Protocol. This is the protocol that translates MAC addresses, the physical NIC ID, to an IP address. And we use ARP poisoning or ARP spoofing to mimic the MAC addresses of other devices, so that your victim is sending you traffic and that you then forward on to somebody else, rather than the victim sending it directly. And the reason we have to do that is because of the differences between hubs, switches, and routers. Each of these devices manages network packets in a slightly different way. So in a hub, basically everyone gets to see everybody else's traffic. It's pretty much a massive broadcast. Whereas a switch switches packets, hence the name, so that only the source and destination get to communicate with each other, and that traffic is pretty much hidden from other people on the network, other devices on the network. So obviously the exception to the rule there is UDP, which is a broadcast protocol. So you'll always see UDP traffic across the entire network. But TCP traffic on a network that uses switches, you'll only see traffic that is being sent to the destination device. And then a router is literally just the layer 3 enunciation of the OSI model, which then routes packets between different networks, not of networks of the same class or subnet. So you need to understand all these basics to actually understand why we use ARP poisoning or ARP spoofing in order to intercept and log the traffic. Promiscuous mode. So you'll hear a lot about promiscuous mode in packet sniffing, and all promiscuous mode is literally a setting that you need to enable on your network card. So by default, your network card will only filter traffic, or you will only send and receive traffic or see traffic that is destined for it. But when you put it into promiscuous mode, it will see all traffic that it is capable of seeing on the network. Obviously, on a switch network, it would be traffic that would need to be either put on a port that is able to view all traffic, or you'll need to do some sort of ARP spoofing to reroute traffic so that you can intercept and log it. And then finally, that brings us to the whole point of this slide, and that is the man in the middle attack. And this is exactly what we're trying to do. So by using ARP, because there's a switch, the victim wants to send the network traffic to this victim over here. But what we do as the attacker is we put ourselves in the middle, hence the name man in the middle attack. So this person is communicating with this person. So the communication still happens, but what they don't see in the background is that all the traffic is actually being routed through your machine there and back again, so that you can actually see the communication happening between those two. And that's pretty much how we go about sniffing network traffic. So what are we trying to achieve with network traffic sniffing? In other words, why do we actually do packet sniffing to start with? Well, the main thing is it's part of enumeration. It helps you identify devices on the network, and it also helps you look at all the information that's flowing about the network, information that you could use down the line to actually gain access. You can also use packet sniffing to identify vulnerabilities. Vulnerabilities in the network you can see through the packet. So packet sniffing is a fundamental skill, and it gives you a very good overlay of exactly what's happening live on a network in an environment at any point in time. So it's a really, really important skill to actually master. And then finally, you can also, depending on how the network has been secured, you can also use packet sniffing to actually gain or obtain user credentials, usernames and passwords. They are sent over the network between servers and clients. So if they're not sent in an encrypted format, well then guess what? You can actually sniff that username and password, which is a very easy way to gain access. So what tools do we use to sniff network traffic? Well, we're going to be looking at ARP Spoof, which is a piece of software that actually spoofs the MAC addresses of different devices and allows traffic on a switched network to be routed through your machine so that you can actually sniff the traffic. We'll look at Wireshark, which is probably the de facto standard for sniffing traffic in the industry. And then finally, we'll look at DriftNet, which is a really nice little tool in Kali Linux, which actually helps you sniff images that float around a network. Okay, great. Let's move on to the last slide. What are the countermeasures? So with this world where we can sniff traffic, what do we have to put in place if we're on the other side of the fence to protect our traffic? And as a penetration tester, what do we need to bear in mind could be the obstacles we're facing in gaining access? Well, let's look at them. The first and most important, and that's why it's in capital letters, is encryption. If the network traffic is encrypted, it becomes really, really difficult to actually log. You'll log the traffic, but you won't be able to actually view the detail in the actual data. So encryption, number one by far, is the most important countermeasure that you can put in place. The second one is you lock your ports down. On a massive network, you would want to have any port that is not being used disabled so that an attacker can't come to your physical location, plug their device in, and then start sniffing traffic. You would want to be able to give the network administrator the power to lock down ports and make sure that all ports that are being used by people who actually work for the organization. Then we want to put static MAC addresses. So you'll see in the demo later, if you have a dynamic MAC address, it's very easy to spoof that and then reroute traffic through your attacking machine. By setting a static MAC address, especially for a gateway or a default gateway, that makes that attack very, very, very difficult to take. Then tunneling and VPN, it's the same as encryption, it's just a different method of it. And there if you VPNing your traffic, nobody can really look into your tunnel. All they can see is the encapsulated encryption data on the outside. And then, as always, we use SSH, not Telnet, because SSH is encrypted. I don't think there are many people who still use Telnet. And then finally, if you're talking about a web application, we always publish our web applications on HTTPS and not HTTP, specifically because we want the traffic to be encrypted. And that pretty much ends this theoretical video. I will see you in a short while in the demo.